here you see M, a matrix M, and you see that this belongs to M4C. M4 means a square matrix of size 4. C means you have to take the entries from complex number. So our matrix M will be M equals to, we can assume it to be like this: A1, IB1, A2, IB2, A3, iota B3. Actually this is iota. I here read I, but that is not the correct pronunciation. Here I means iota. And here this is the first row and the second: C1, ID1, C2, ID2, C3, C3, ID3, C4, ID4, and the third row will be E1, I, F1, E2 plus iota F2, E3 plus iota F3, E4 plus iota F4, and the last row G1 plus IH1, G2 iota H2, G3 iota H3, G4 plus iota H4. We can assume this matrix M like this. And now we have this relation. If we impose this relation, then the same matrix, that is M, reduces to this H matrix. Okay, so first we impose let us impose this condition, okay. So imposing this condition, we get two new matrices, and both will be equal according to this relation. So let us write, and that will be like this: transpose of M, and you see transpose of M will be A1 plus IB1, A2 plus IB2, A3 iota B3, A4 iota B4. Okay, the first column. Now the second: C1 iota D1, C2 iota D2, C3 iota D3, C4 iota D4. Now the third: E1 iota F1, E2 iota F2, E3 iota F3, E4 iota F4. Now the last column, and that will be G1 iota H1, G2 iota H2, G3 iota H3, G4 iota H4. Okay, now this is a transpose of M, and according to this relation given in the question, that equals conjugate of M. So to get the conjugate, we have to replace the iota with minus iota, and in doing so we have A1 minus iota B1, A2 minus iota B2, A3 minus iota B3, A4 minus iota B4, okay. Now the second row: C1 minus iota D1, C2 minus iota D2, C3 minus iota D3, C4 minus iota D4. The third row E1 minus iota F1, E2 minus iota F2, E3 minus iota F3, E4 minus iota F4. Now the last row G1 minus iota H1, G2 minus iota H2, G3 minus iota H3, G4 minus iota H4. Okay, now we compare. Here we compare, if the two matrices are equal, then their corresponding entries must be equal. So this will be equals to this one. And if we equate, that is A1 plus I B1 equals to A1 minus iota B1, then this gives us B1 equals to 0. Okay, so here this thing, you see, if you compare the diagonal entries, then the imaginary part of all diagonals will be 0. Okay, so I do the changes in the matrix M. So here you see B1 will be 0, accordingly D2 will be 0, D3 will be 0, and H4 will be 0. Okay, so now our matrix matrix M has reduced. Now we compare the next entry here. Now we have done along the diagonal. Now we go along the row, and the second entry in the first row, if you compare, then at the place of C1 D1 we can write A2 minus B2. Okay, so see here will be A2 minus IB2. Okay, if you go in the same way, I mean you compare all the entries, then the matrix will reduce, as I show you. Here will be A3 minus iota B3, here will be A4 minus iota B4, and here will be C3 minus iota D3, and here will be C4 minus iota D4, and here also this will change, and here will be E4 minus iota F4. Okay, now when we have imposed the condition, this condition on all the corresponding entries, then this matrix, you see this matrix now becomes H. Okay, so I here erase this one. At the place of this one, now I write H, because now this matrix has become H. Now you see here we have to find the dimension of H, and the dimension of H will be the distinct real numbers. Here you see over here you see over R means real numbers. So we have to choose in this, you see inside the green enclosure, you see there are real numbers and complex numbers. In those we have to count the real numbers. So I show you the real numbers, the distinct real numbers. Here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Okay, I will not take this one because I have already taken A2. Here you see A2. Okay, so we have to count the distinct real numbers inside this matrix H. So those are, you see, those are 16 in numbers. So we have to choose that option in which we see this number 16. And if you go through the options, then obviously the B is the correct option, because in this we have this number 16. So this question is done now.